equation a little bit to contemplate a different scenario where we have lots of chlorine, or what happens if we have more and more chlorine. It doesn't just stop at the simple methyl chloride. It could keep going. So we're just going to write a little bit about this subtle detail. This is known as consecutive reactions. A consecutive reaction is basically where the products of a prior reaction become the reagents in a subsequent reaction. So consecutive reaction isn't really anything special. It's just that one product is formed. It can continue on and then become a reactant and do something else. So we're going to talk about two different cases here. We're going to talk about monochlorination conditions. And I'm going to leave a little space here. Polychlorination conditions. Monochlorination conditions would be where we have an alkane and we go to some sort of single chlorine attached to it. Okay. So if we put one chlorine on. Polychlorination, we could have an alkane, and as we previously saw, we could have multiple chlorines put on it. So alkane is only carbon and hydrogen, right? Monochlorination conditions happen when we have excess alkane. Or more specifically, when the concentration of alkane is much, much greater than the concentration of chlorine. This would be called monochlorination conditions. If we have a large excess of alkane, chlorine is going to be used up monochlorinating each alkane before it ever can polychlorinate. If we want polychlorination to take place where we have an alkane with lots of carbon-hydrogen bonds, we want to swap them all out. This happens when we have excess or when we use excess chlorine. So this would be a case where we have concentration of Cl2 is much bigger than the concentration of the starting alkane. Okay, so these are two subsets of the radical chlorination reaction. I'm going to tell you right now, most of the time, I'm going to be concerned, and you should be concerned with monochlorination. You have methane, it reacts with Cl2, gives methyl chloride. But I want us to just be aware that if we use lots of Cl2, lots of excess Cl2, this reaction can take place subsequent or multiple times. It becomes what's called a consecutive reaction. I know this might seem disconcerting to many of you right now, these ideas, but I think if you practice the notes in the order that we did them today several times, this will make perfect sense to you in the activity of doing on your own the polychlorination of methane till it goes all the way to CCl4. I think this is a perfect activity for you to practice on your own. We could talk about it in office hours on another day if it's unclear. We have about 20 or 25 minutes, and we're going to continue on now to something that'll be a little bit more fun, a little change the direction of our thinking, and it's going to go back to reusing some skills that you learned earlier in this particular class about predicting products. Let's actually move on now to other alkanes. We're going to use different logic centers in our brain now to think about this. We have this new reaction called chlorination or monochlorination of methane. We're going to look at what happens when we do this particular reaction with other alkanes. Well, I'm not feeling too adventurous today, so the second most simple alkane is ethane. And we're going to take ethane plus Cl2. We're going to heat it or shine UV light on it. And we're going to do this reaction under monochlorination conditions. When I write this, it just means I want you to consider what happens doing one substitution for one hydrogen with one chlorine. If I wanted polychlorination, well, then there would be 6 chlorines in this, or lots of different products. But for monochlorination, if we take ethane, react it with Cl2, we're going to get HCl plus what? I want you to draw in this box what you think the other product is, and I want you to ask yourself, how many unique products can we make? Methane had only 4 hydrogens all attached to carbon. If we substituted any one of those with chlorine, it'd be the same product as if we picked any other hydrogen. Ethane has 2 methyl groups. Obviously, we take one of these hydrogens and put chlorine in it. We'll have a chlorine dangling off this side. Or, well, what if chlorine attacks or chlorine radical attacks this carbon-hydrogen bond or this side of the molecule? We'll put a chlorine in here. Is that a unique product? Or is that a different product? How many unique products do you think there are if we take ethane and monochlorinated, meaning we're going to substitute just one hydrogen for chlorine? How many unique products can we possibly make here? Try and draw them all in the box right here. Monochlorinated ethane. The answer I hope you get is that we can only make one unique product. We'll make chloroethane. And this would be exactly identical if you chose the left methyl group to work with. These 2 molecules are absolutely identical. They're not unique. Okay? So this particular reaction, when we take ethane, react chlorine with it, heat it or shine UV light on it, and we do it under what's called monochlorination conditions, we can only make one product. Another way we can look at this, we could draw ethane in expanded notation, and when chlorine radical picks off one of these hydrogens, are there any differences between if it picks this one or this one, 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 this one or this one? There's absolutely no difference. If we picked any of these, chlorine here, here, or here, it's the same compound. It would be called chloroethane. If, on the other hand, we pick this one, put a chlorine here, or a chlorine here, or a chlorine here, that compound ultimately would be called chloroethane. This particular molecule has a high degree of symmetry. Right down the middle, there's a mirror plane. Things on each side of this plane are the same. These 3 hydrogens are all the same as one another. And so at the end of this, doesn't matter which one of these 6 hydrogens we pick, they all lead to the same product. Okay? That might be very simple for many of you. It's okay. What if we took propane? What if we took propane plus Cl2, monochlorination conditions? We're obviously going to make HCl. I don't really care about this for this activity. How many unique products could you imagine if propane reacted with Cl2? Right? Are all 8 of these hydrogens the same? Are there any differences? Think about this and try and draw all the unique monochlorination products you can imagine. I'm just going to give you a quick clue. There's more than 1 and there's less than 8. Okay? That's a little quick clue for you. Insider tip. This little gap here, I'm giving it to you to fill in what you think the answers are. If you leave it blank, you're missing an opportunity to try something, check your work. If you're wrong, you can learn from it. If you're right, I can affirm it. So try and draw in the unique products you envision. Draw the ones I think that could happen. I can easily imagine one of these hydrogens being substituted for chlorine. Doesn't matter which one of the 3 I pick, we would have 1 chloropropane. What about this one here? If I'd taken one of these hydrogens, plucked it off, and put chlorine in its place, our molecule would have chlorine dangling off the left side. That would also be 1 chloropropane, exactly the same. What about this middle one? If I pluck off this hydrogen, would it give us this product? It actually doesn't. It would give us something else. We would have 2 chloropropane. So I hope this is what you drew in your notes. Notice that I'm naming these compounds. That's a great way to tell if they're the same or different. If we had drawn in our notes, or you had drawn this particular product, and you had some uncertainty whether it's the same as this or this, you could name it 1 chloropropane, 1 chloropropane. This is not a unique product. This is 2 chloropropane. This is a unique product. So we're going to use symmetry, we're going to use drawing to anticipate how many unique products there might be. Another way we can do with propane